My name's Nathan Ray and I'll be your host today, and today we're going to be discussing presetters. A couple of bits of housekeeping before we get going. Number one is I can't hear anything you say, unfortunately. This audio is purely one way, so please don't sit there shouting at your screen thinking I'm being rude. It's nothing personal. There is a question button just down here. If you click that, you can ask any questions you like, and at the end we'll be going through these together in a Q&A session. Secondly, if you look up the top at your event board, there is a button where you can download any of the documents, flyers, information based on everything we discussed today. So, without further ado, let's jump over into our tour room and we'll get going live. Hello, and as if by magic, here we are in sunny Sheffield at the tour room in our Nicken Innovation Centre. So, thank you again, everybody, for joining. As you'll see, we have a lovely E46 LAIS presetter here from Elbow Controlling Nicken that will be kind of the focus of our session today. So what I'll do to start with is we'll just run through what the format of this session is going to be. Hopefully it won't be too much of me just talking at you, but what I will do is we'll start off by just discussing presetting in general. We'll discuss what presetting is, what the benefits of presetting are, why you may use a presetter versus other maybe more traditional options, or setting tools on a machine, for example. We'll do a quick demonstration of a number of common tools that you might see on a regular shop floor, how we would measure those, the benefits again of a presetter versus on-machine inspection. We'll then go through what to look for in a presetter. So if you decide that presetting is the way for you, what should you look for? You know, what are the kind of key features that you need to be looking for when you're trying to spec which presetter you would choose and you would ultimately invest in? We'll have a quick overview of the Elbow Controlling Nicken range. Again, all of these documents for the whole range are uploaded in the event board for you to download. So we'll open up to the Q&A session at the end as well, where you can ask questions based on all of those. And then we've got the ROI and payback, which I suppose is the bit that most people are interested in. It's that bottom line. It's what savings can we really realise from using a presetter versus another form of technology, okay? So the Q&A session at the end, please do feel free to ask questions as we go. I may brush over them and save them till the end, but don't worry, we can do a full demonstration at the end. So if you think there's something that you see during my demonstrations that you'd like us to go in a little more depth in, again, if you raise that at the end, I'll be sure to cover it, or we can arrange a separate one-on-one session after this. So let's jump straight in, shall we? What is presetting? Now, I'm sure most of the people in the room, myself included, have got a background in engineering, or at least know about machining in some sense. Now, as with a machine tool, we need to know the position of everything that we're doing. We need to know the length of our tool. If we don't know the length of our tool, we're going to be producing scrap. It's either going to be too long, too short, and we're going to have trouble. So we have to set a tool. And this is something that even from the early days when we've all started with apprenticeships, we've learned maybe even just touch on. So wind your tool down, touch your job, and take that as your reference, as your tool length. I mean, these days we have some more slightly advanced methods of measuring tooling, and presetting is one of those. So we might use, for example, an on-machine tool setter, where we have a touch probe or a laser on a machine. But presetting, I suppose that the clue is in the name, pre-setting. We're setting the tools before they get to the machine. So you're not wasting machine time. Your machine is used for production, and that's what you're investing in a machine tool and an operator for. So if we run through a few of the sort of key benefits of presetting, of setting your tools before they get to machine versus setting on machine, I suppose the first one really is a time saving. Every minute you have a machine sat there idle, it's a cost. You're not producing parts, which is what your machine is intended to be doing. I'm sure your machines have an hourly rate. Even if your machine is sat there for 10 minutes idle or measuring a tool, that is a direct cost that your business is incurring. By taking that process offline and moving to a presetter, making sure that your tools get to the machine ready, you're removing that cost. You're running it in parallel with your machining, not instead of machining. There's a direct cost saving, so obviously a time saving equals cost saving. But also, if you were buying a piece of measurement equipment for every machine tool, okay, you might think that's a relatively modest investment on an expensive machine tool. But if you multiply up a tool setter, maybe 1, 2, 3,000 euros, for example, and multiply that by the number of machines on your shop floor, you'll see that soon quickly adds up. A presetter, on the other hand, and we will demonstrate this shortly, can be used one presetter for many machines. And we can keep track of the references within the presetter, we can calibrate for each of those machines. So actually you only need one presetter to service a large number of machine tools, so you've got a direct cost saving there as well. A presetter, in our experience, also offers a lot more control than setting tools on the machine. Commonly, when you set a tool on a machine, you're measuring one of two things. You're measuring your length or stick out of your tool, and maybe even your radius or diameter. But really, that's about it. Now, with a presetter, on the other hand, you have really got a lot more control. And again, we'll touch on this in a moment when we go into a live demonstration, but you can manage a tooling set, a tooling list, you can put tolerances in there. So maybe you have a very tight tolerance or a very particular stick out that you need for clearance on a job. Well, the presetter can make sure that whoever is assembling and setting that tool is getting that correct before the tool ends up in the machine and potentially causes issues, causes a collision in the machine, these sort of things. So we can put tolerances in, we can also check a tool. We can check that, yes, we have got a new tool, it's not worn. Actually, here in our innovation center, we inspect tools before they go on the machine, but also after the machine, as part of a closed loop optimization process to drive costs down of all of your manufacturing processes. Because even another 10, 15, 20 minutes use out of a tool can result in big savings when you're in production. So the presetter can gather, collect, and control data that really can be used to optimize your entire machining process in a closed loop sort of system. We can also measure with a presetter a lot more features than what you classically can with on-machine measurement. So not only are we taking time out of our manufacturing, but we're also very limited really in the measurements we can take. If you have a special form tool, for example, with a custom radius on or a custom feature that is absolutely critical to your final part, well, the presetter can allow us to measure this in a way that you really can't do on machine. So we're almost validating that that tool is correct and saving time before it ever gets onto machine and before your component then ever ends up in the inspection bay or on a CMM. So very quickly, I mean, that's a very quick overview of why you might want to use a presetter versus on-machine inspection. But I suppose the best way to show you is to jump straight into a live demonstration. Now, I have here an E46 LTWAIS, which, yes, is a bit of a mouthful, but what that basically means is this presetter has the majority of options that you would see on a presetter from the elbow control unit and range. So if there's anything you want to see, this is quite a good machine to demonstrate on. So, what you should now be able to see up on the screen is, in the top right-hand corner, my beautiful face. In the rest of the screen, you should be able to see a live screen share of what I'm seeing here on the presetter. So this is my control interface, but this is also where I'm going to be able to visualize the tools. Now, what we're going to demonstrate here is the tooling tables and how we're going to manage machines, because that's obviously very important in terms of cost saving versus on-machine measurement. And then we'll measure a few sort of typical tools, and I'll show you just how quick and easy this is. Okay, so let's jump straight in. You'll see here, simple press of the buttons. Now we have a list of a number of different machine tools. So we're not just talking one or two machine tools here, we've actually got quite a list of machines. So I'm going to pick this Mazak VTC 800 as an example. It's got a HSK 63 taper. And I can go into the settings area and we can see I can define a lot of different things about that machine. I can pick the holder, the spindle taper, for example, the type of machine that is. So before we even begin, we're keeping track of a machine shop with a number of different back ends, because it's very rare that you'll see a machine shop with all one taper. So the presetter handles all of this for us. You set that up once, set it, forget it. Okay? There's a lot of other settings that we can set in here, millimeters, inches, all these sort of things. So once that's set up for your machine, it's done, it's dusted. Okay? Once we've picked our machine, we have tooling sets. Now our tooling sets might be for particular jobs, where we have a list of tooling. And once we're inside our list of tooling, you'll see for every single tool in there, we can set a number of different things. We can set a theoretical, the stick out, for example, that you're aiming for. We can put a tolerance band in there, plus minus, corner radius. We can use DXFs for comparison. So there's quite a powerful tool here. And again, we've got a number of different ways of doing this depending on which model in the range and how advanced you really want this to be. But this is data capture. This is using data to optimize your process. So we have a tool selected. We'll start off with a pretty standard end mill. So this is just a 5-flute solid carbide end mill, maybe the sort of thing that you would see on a regular shop floor. Now, I'm going to put this in our spindle on the machine, tighten that up in the machine. In this instance, we're actually using a manual clamping spindle. So I've got an Allen key here, I'm going to tighten this up. Now, depending on your requirements, your budget, there are a number of different options. We can have vacuum clamping, for example. We can have assisted clamping. So we have got a number of options, but in this case, manual. We're going to bring our tool into view. Okay? Now this is operating, I suppose, in the simplest way that a presetter would. You'll see we have a crosshair in the middle of the screen. We're going to bring our tool into focus. When we're happy that our tool is in focus, we'll lock that in position, and we'll wind the tool up to our crosshairs. You'll see as we start to get close, our collimation bars appear, and we're going to wind that tool until our visual indicator starts to go green. Okay? On both X and Z. And once we're there, we can record both of those values by a very simple tap of Z and X. Done. That tool's measured in exactly the same way and with exactly the same information that you would get having done this on the machine. So you see how quick and easy that is? We've put the tool in the spindle, we brought it into view, and we've wound to the bars. Okay? Perfectly simple. But what if you're really lazy, like me, and you decide, I don't, this winding normally on the machine, it does that for me. Well, we have another option. At the top right of the screen, you'll see these are our different measurement options. We can select auto collimate, and you'll see the blue lines on the screen now are tracking the uppermost Z value and the outermost X. So as we rotate our tool, if we're even lazier and we don't want to have to rotate that tool even, we can use our profile on memory function, and what that's going to do is it's going to record and measure from the outermost Z and X as I rotate the tool. You see, so it's picked up there, our X and Z value, and we can record them. So in this mode, it's even easier. It's tool in the machine, auto collimation, profile on memory, and there we go. We've measured that tool, we've got our measurements, we're ready to go. And then we can print these measurements out, for example. We can transfer them to the machine using something like Tool ID. But that is how straightforward measuring a standard end mill is. Now, okay, you might want some more advanced features. You might want to take some measurements. You might want a radius calculation. Well, we have a button that will automatically try and find some geometry in there. We could, using our crosshair, measure a circle where it's going to start to fit a circle, freeze that onto the screen. Okay, so there's a lot of other further measurement features that we can perform from this screen. So that's a standard tool. Let's have a look at something a little bit more interesting. Okay, and what we're going to do now, we'll take this tool out and we'll have a look at a boring bar. Now, a boring bar is an interesting tool for a presetter because on a machine tool, if you were going to measure this, and this is a Nikon ZMAC boring tool, again, a common item that you might find many different shop floors, it has an adjustment. And what you would normally find is that you put this into the spindle of your machine, you set it somewhere close, you have to take a test cut, measure what you just cut, adjust the boring bar, maybe take another cut, and all of this is time. It's expense, it's not a very efficient process. But this is something where a presetter really does shine because I've set this tool somewhere close. So in exactly the same way, I'm going to load that back into the presetter and clamp it up. I'm going to select actually for this code the most basic measurement method of the presetter. And this is the same for the full elbow control unit and range, okay? I'm going to bring that tool into view. It's my, in this case, bottom right-hand corner. I'm going to make sure we're in focus and lock my C-axis, okay? So we are in focus with our cutting edge there. We'll wind our Z to where we're happy with. But what I'm going to do in this case is, instead of measuring where that boring bar is set, I'm actually going to set my presetter now to the diameter of a hole that I'm aiming for. So let's say I'm aiming to produce a 30.9 millimeter diameter hole, okay? 30.9. I'm going to lock my X in place there as well, and then I'll adjust the boring bar live. And what we'll do is we'll wind the adjustment on the boring bar until it meets that crosshair that we're aiming for. So we'll polymate it this way by adjusting the boring bar. Okay, and there we go. We've now got a set diameter. We can lock that in place, put that on our machine, and we know what diameter that boring bar is going to cut now. So we've removed a process from the machine tool entirely. Plus, there's no extra coding on the machine tool. There's no having to remember M codes, having to put extra functions in or any manual intervention on the machine. It's done, it's ready. All the operator has to do is load this tool into the machine. And that's really where we want to be. We're aiming for lights out. We're aiming for load the machine, walk away. So that's the standard end mill. Make sure we unplug our axes. Third and final tool we'll have a look at. So standard end mill, boring bar, is a face mill. So again, a reasonably standard face mill. On this, we're going to measure in the kind of what I would say is the third method. So we've got the fully manual, the auto collimation, but we're going to measure this automatically. So we're going to bring this tool into view, much like we have with the last two. Make sure we can see where that cutting edge is. Okay. In auto collimation, you can see we're still picking that up. And I'm going to use a feature called region of interest. And all this does is it tells the presetter, this is the part of that tool that I'm interested in. Whatever is in this square, rather than the whole field of view. Okay? Region of interest is on. Now, up towards the top right again, where we select our measurement types, I'm going to select fully automatic on the touch screen. I'm going to tell the presetter we want every insert or every flute. And I'm going to press go and take my hands off. And you should see the presetter is rotating itself. It's auto collimating, it's finding our edges for us. And in a few moments, when it's finished, we should get a nice plot down the bottom showing us our measurements for actually every single cutting edge or insert on that particular tool. So this is, again, is more data than what we would get if we'd have done this on a machine when that tool was rotating. We'd have simply got a Z and an X. What we're getting here actually is a graph of the measurements of Z and X for every different insert. And this can actually be quite powerful. Not only can we hint at whether there's any run out in our tool, and if it's something that you want to see, just let me know in the comments, and I can do exactly the same with the end mill. But we can see here that we've got one insert that's particularly high and one's particularly low. If we look at number 1, I'd be looking at this saying, well, that's low. Of course, if we put some tolerances in, this would highlight any edges that are in or out of tolerance. But if I select edge number 1 and ask the presetter to take me to that edge, it will bring that into view, and then we can start to inspect. So I'll turn off my region of interest just to make it clearer. Okay, we can see, maybe this insert is slightly worn, but the full range of presetters have an inspection mode also, where we can switch the camera and we can start to have a bit more of a look into that tool. Why is that lower? And we can see here that quite obviously this insert is heavily worn. maybe we would like to take a measurement in exactly the same way we've done on our measurement mode. We can also measure from our inspection mode. If we use our crosshair, maybe I want to measure just a vertical measurement there. We can insert that as a measurement. We can report that out. We can enter that into the database. Maybe this tool is usable some more. Maybe it's not. But again, it's using data to fully optimize our machining process. Okay? This particular preset is just while we're here. We can actually inspect from various different edges. You'll see here, this is a side view of that tool. We have a camera on the top as well. So if you have some really fine processes where actually you've got some very expensive custom tools that you need to inspect, or maybe you have a tool you can't buy anymore and you want to take some measurements so that you can duplicate that tool. Really powerful functionality here that you just simply wouldn't get with on-machine inspection. Okay? And these are pretty standard features for the entire range. Certainly the inspection and measurement modes are there for the full range. Now, this presetter does have some more advanced functionality. We can actually take DXFs of a tool, for instance. Again, we wanted to put that into a CAD package. And we can also show DXFs on the screen. So if you have a drawing of a tool and you want to check, again, just as a quick inspection before that tool goes into the machine, we can load a DXF onto the screen with tolerance bands, and we can simply wind our tool into those lines that are shown on the screen. Quick visual check, yes, we're happy, tool goes into the machine. So you're leaving your machine to produce parts and your machine operator to be the expert in running a machine. You know, they are a valuable resource. And you're putting the EOS on the tool room, really, for setting your tools. So, again, that's kind of the end of the quick demonstration. If there's anything else that you'd like to see, please do drop them in the comments, even during the question and answer session, and I'll do my best to show you. But you see how quick and easy that is? 3 completely different tools we have here, and every single one of them we can measure and take unique features from very, very quickly and easily. So, what to look for in a presetter? You know, I keep saying ease of use, ease of use, ease of use, but there are other things really with presetters that you should look into as well. I'd say probably most importantly is that you need a solid construction. And this is very similar to when you are purchasing a machine tool. You want that machine tool to produce quality parts day in, day out. And yes, there'll be some maintenance, I'm sure, but you want the structure of your machine to be fundamentally strong so that if the environmental conditions change, you still know you're going to get quality parts out of that machine. So you need a good, strong construction. For example, and we can see this with this presetter here in the full elbow control Nikon range, is a solid granite construction. You know, we're using a material that is very, very thermally stable. So you can put this presetter anywhere. It should read the same today as it does tomorrow, as it did yesterday. You know, case in point, CMMs. The CMMs that we use and that we have in our factories, they're all made of granite, and there's a reason why. It's because for a piece of precision measurement equipment, you need a solid construction. You know, you'll find some presetters that are lesser construction, that use software trickery to try and compensate, but fundamentally it's not going to be as good as a solid construction. Second, I'd look for interchangeable spindles. Now, there's no harm, and it's quite common to see, pick a large taper, a 50 taper for example, fit a spindle for that, and use adapters for your measurement. Now, yeah, that does work, but the problem is, as you get smaller and smaller, as you get towards the sort of 30 tapers and smaller, the likelihood is you're doing some very, very precise work. Every time you fit an adapter, an adapter, an adapter, there is a tolerance there. There has to be. Now, if you're chasing microns, you're adding error to the system. So, personally, I'd be looking for something that you can very quickly and easily change spindles with. And I'll demonstrate the sort of thing and how quick and easy this is. We have fitted a HSK 63 spindle here, and with nothing but a simple pull, that spindle's removed, and a different spindle, in this case a Capto C4, will push straight in, and that's now ready to go. So it really is that quick. Okay, yeah, we can put our setting gauge in, we can reset this tool now, just make sure that that spindle is where we want it to be. But again, there's no added time there, and you're minimizing the tolerance stack up. Hopefully I've shown you how user-friendly a presetter can be. Because again, what we're talking about here is optimization and efficiency. It's not particularly efficient if people are having to get the manuals out every time they want to use a piece of equipment. It should be very intuitive. You want something that anybody on the shop floor can walk up to, and even if they haven't used it for a number of days, weeks, or months, remember straight away how to do it. And what you should have hopefully noticed is that, certainly with this presetter I've been demonstrating here, everything is done from one screen. Okay, this example has two screens. We have our full TP32 tool management on the right-hand screen, which is something for another session entirely. But the main presetter screen on the left, it has icons, they're all there, they don't change. Everything is within one touch. There's no hidden menus. It should be very, very straightforward with minimal training. Again, training is a cost. You know, it's taking engineers out of the job they should be doing to teach them how to use something. The presetter that you look for should really be quite intuitive. It's better than remembering M codes, trying to set on a machine. You know, there's no prior knowledge, just a few pointers in the right direction and away you go. As with any piece of measurement equipment, you should really get a presetter calibrated in much the same way you would a CMM. You know, if you're chasing microns and you want to maintain quality for years and years and years, you should calibrate. And I'm sure a number of quality systems that you have implemented within the workshop on the shop floor would require this anyway. But I'd look for a presetter from a supplier that has local support. Somewhere that you can get your presetter calibrated and any essential maintenance done and certified so that you know it's performing at its peak. You wouldn't leave your CMM for years without a calibration. You really shouldn't do the same with your CMM, with your presetter, sorry. So local service and support is key, really. And then finally, connectivity. We've all seen how fast technology has developed, even in the last few years. So the last thing you want to do is invest in a piece of equipment that's going to be out of date tomorrow. I, for one, believe that manufacturing is going to continue. You know, we're hearing more and more about Industry 4. And to me, what that is using data and connectivity to optimize our process. You know, we've spent, and we do still spend, countless hours on making sure that the machining inside our machine is optimized, that we're making the tools last as long as they can. So let's also optimize the flow of information and the flow of tooling and the logistics around on our shop floors. So let's make sure that if I measure a tool here, I can send that data through something like Tool ID straight into the machine without having to remember. And I'm sure there'll be a number of people in this room, and I include myself in this, that have previously measured a tool somehow, written the number down on a piece of paper, gone to punch that into the machine tooling table, maybe got two of the numbers the wrong way around and have had an accident on the machine. Quite common. So I'd be looking for a presetter that can interface directly with the machine tool through something like a post-processor, a tool ID system, these sort of things. Because again, that is a way that we're going to take error and inefficiency out of our machining and production process. Again, as we've just touched on, you don't want something that's going to be out of date, so you want a piece of equipment that's going to have free firmware and software updates, and that's again something that the whole elbow control unit can range benefit from. If you're getting your presetter service regularly, that's something as well that our local support teams can do for you during the service. So what I'll do very quickly is put up on screen a quick screenshot of, I suppose, the ECM range. You're probably not going to be able to see this, I'm fully aware. There's far too much information there to put on a slide. So this will be downloadable in the event board. And again, if you want to run through this with a local business manager, myself, any of the team here at the Innovation Centre, then please do get in touch, drop us a message. But the kind of take home from this, at an overview look, without even being able to see what is said on it, is that the entire elbow control in Nikon range, from the most basic entry-level presetter to the most advanced full CNC, is based on the same construction. It's all based on a solid granite construction with a simple-to-use interface. So really, this is an invitation for you. If presetting is something you're interested in, drop us a message. We'll be more than happy to discuss your requirements with you and go through this table. There's a configurator on the Elbow Control Nikon website where you can put in your requirements, and it will give you a presetter that is perfect for your needs. Or give us a call, drop us an email, and we can go through that with you. I suppose the thing that we're all most interested in here is the direct cost savings that really are measurable. It's all well and good me talking about optimization here, there, and yes, we can measure that, but what are the direct cost savings from implementing a presetter in a tool room versus measuring on machine? So what you'll see on the screen now is a calculator that we use. And again, this is something we can run through with you because I'm sure every person's shop floor is slightly different. But in this example, if we just go through it together, you'll see we're working on an example of only 4 machines. So there's 4 machines in this factory. 1 hour in every shift is spent setting tools on a machine. There's 2 shifts per day. And the average hourly rate for a machine, in this case, is £65. Now, I know that can vary massively depending on the type of machine, the age of machine, etc. But let's just take this as an example. Now, if we multiply that out, our cost per day, every day, of setting tools is £520. Okay, that might not sound like a lot, but every day that soon adds up. So the example here, we put a presetter purchase price of £35,000, so certainly not an entry-level presetter there. But running the numbers through, your £35,000 divided by the £520 per day means that within 67 days, your presetter's paid for itself. Now, yet there are certainly a lot of variables that we haven't included in this. If we take into account things like the cost of your on-machine tool setting, for example, that will be much shorter. But in this case, 67 days is all it would take to pay that presetter back by taking your setting of the tools and running in parallel with your machining in a streamlined, optimized method. Once you've paid that back, of course, your machines are in production all the time. So you can be making a saving of £2,600 every week, 40 hours of machining time. So, these aren't insignificant numbers we're talking. By a quick change in your process and your working methodology during production, we really can realize direct savings. So again, open invitation, please do ask, discuss with your local representatives, and we can run through this with you. We can put the numbers that you would have on the shop floor into this calculator and just start bouncing some ideas around. We are here to help ultimately, and this is something that we do day in, day out here at our innovation centre. We're always looking for where can we save a little bit of time, a little bit of cost, and then sharing that with our partners. So that's probably enough from me talking, I suppose, at you all. I hope that's been kind of interesting and we've learned something. So I'll open up now to a bit of a Q&A session. So if you have any questions for me, if you'd like to see something else demonstrated that we haven't seen already, or if you want me to go into a little bit more detail on anything, then please just pop that in the comment section there and I'll do my best while we're here. Likewise, if there's something very specific that you'd like to have a look at, maybe you have a specific tool that you'd like us to have a look at and inquire how maybe we go about measuring that, then absolutely we can either do that in another session, you can send us a tool, and we can put something very similar here and demonstrate that for you. So I'll start now, I'll just read through a few of these questions that have popped up I've seen as we've been going. Can the zoom be changed to look at small tools? Absolutely. If I show you the screen again, you'll see over here down in the bottom left-hand corner of the screen we have a digital zoom. So I'll put a tool back in. This is quite a large tool anyway, but you see we can digitally zoom into that up to 4 times. We also have options certainly for inspection of higher zoom lenses as well. So if you're only ever going to be measuring particularly small tools, there are options available where the lenses and the magnification of the unit standard will be higher than on this particular one that we're looking at here. Okay. What is tool ID? I know I've touched on this a couple of times, and I'll keep this relatively short and sweet. There is a document in the event board that explains what tool ID is. There's also a video on YouTube. If you search something along the lines of Nikon tool ID, you'll, again, unfortunately for you, see my face here in our Innovation Centre doing a full walkthrough of tool ID with preset tool and machine. But at its simplest, tool ID is a way of using a barcode or a QR code on a tool to scan at the presetter, because each of these QR codes are unique. We can scan that tool at the presetter. All of that tool's information will be pulled up onto the presetter. We can measure and save that data into the cloud. And then when we get to the machine, using a small IPC and a network interface into the machine tool, we can scan the tool again and load that information straight into the tooling table of the machine. So it automates that reading and writing of information. You're taking out the manual process of having to remember a number and put that into the machine tool. I'm sure maybe some of you have heard of things like the Balfo system. I suppose it's quite similar, but you don't have the issue of having to buy data chips, which are quite expensive, and drilling all of your tool holders and gluing them in and paying for expensive hardware on the machine tool. It's all done through existing kind of software interfaces and minimal additional hardware. So yeah, if you want more information on that, please do just drop us a note, drop us an email, and I'll make sure we send that over to you. Okay. What presetter would you recommend for a small machine shop that is value for money in terms of capacity? I suppose the best thing to do here is to point you towards the product configurator, where if you do put your requirements in, your size, number of tools per day, these sort of things, it will recommend you a tool. But a good starting point would be something like the new, which is actually relatively brand new, E346V Plus. You get a lot of functionality and a lot of features there for a very good price, really. It's borrowing the software from some of the higher level presetters and putting it on a more mid-range presetter. So that would enable you to do a lot of what we've demonstrated here. Again, if you want more information, you've got the documents to download here, you've got the website, and we've got local business managers in most regions that will be happy to discuss that with you. Okay, is it possible to measure turning tools? Yes, absolutely, in exactly the same way that we've done here with our milling tools. As long as we have a machine reference, so you have a tool holder of some sort, Capto, for example. I know one of the spindles that I've got here is a Capto spindle. Yes, we can measure turning tools in exactly the same way. All we need is that reference. Obviously, with turning tools and changing of direction, that can be something that you need to bear in mind, but a combination of the tooling management that is built into the presetter, and if you want to go that far, the TP32 tooling data management, we can start to control that, so the various different angles and the measurements also. So yeah, turning tools are absolutely something that we can measure. Do the presetters need to be in an inspection room? Well, you'll see here that actually in our Innovation Centre, I am in a temperature controlled room and it's a clean environment. Now, really this is up to you. It depends what's best for your situation. Normally a CMM, a piece of measuring equipment, yes, you would put that in a temperature controlled room. Does the presetter need to be? Well, the argument is no. Actually, the presetter is made of such construction, certainly the elbow control Nikon range with the solid granite, that it's kind of resilient to temperature change. So putting that on the shop floor next to your machine really shouldn't be an issue. Whether it gets hot on the shop floor, cold on the shop floor, your presetter is as good as anything, is as good as your machine tool is going to be at dealing with those temperature fluctuations. So yeah, please don't pour oil and all sorts into your presetter. Treat it like a piece of measurement equipment, but absolutely it can be based on a shop floor if that's what works best for you. Are updates always free? Yes, software updates. For as long as we're making updates and as long as the operating system and everything is current, yes, we will provide software updates. They're actually downloadable from the Elbow Controlling Nikon website yourself, if it's something that you want to do, or if one of our team is servicing your presetter for you anyway, we can update that for you. So yeah, absolutely, software updates are included. What else have we got? Updates always free, yeah. I mean, is there anything else that people would like to see while we're here on the presetter? I'm open. I've got plenty of time. If there's anything you guys want to see, I'm sure you've all got jobs to be getting back to and busy days. But yeah, please do ask away. I don't think I've missed any of these just yet. Okay, so if that's it from everyone, that's absolutely no problem. Obviously, you have our contact details. Personally, I'd like to thank you for coming and joining in on this session. It's been my pleasure, absolutely. Sorry, just another quick question. Clamp tools on the spindle. Can you clamp tools on the spindle? I would advise not. Okay, changing an insert maybe, but let's not forget this is a piece of precision equipment. If you're putting any unnecessary loads, if you're tightening a tool up on the presetter, it's probably not advisable. It's not to say you're going to break anything, but you wouldn't go to your CNM and start pushing and pulling and tightening things. So I'd follow the same logic with your presetter. You're not machining parts on here, it's precision equipment, and let's treat it with some respect. Okay. So I'll wrap this up here. Again, you've got contact details, files, everything you need if you have any more questions. Thanks again, and enjoy the rest of your afternoon. Thank you.